for each other. All right, no. Okay, let's do this guy. All right, so this is how we do this guy. We want this guy over here to be 0. So first thing we're going to do is get rid of that 3. It's got to equal 0. That way we can do our signs thing. We can say plus or minus or whatever. So I'm going to subtract 3 from both sides. And when I do that, something ugly happens. Subtract 3. All right, look at this. I have to combine those. Boo. If I'm going to add fractions, what do I have to have?
Common denominators. Oh.
So the 3 currently has a 1, but it needs to have an x minus 5. So I'm going to multiply top and bottom by x minus 5. Let's go. Let's write this out. We got 2x plus 7. I'm sorry, 2x minus 7. 2x minus 7 over x minus 5 minus 3 times. Wait, let's just do it. What's 3 times x? 3x. So we have 3x. 3 times 5. Negative 5 is negative 15. All over x minus 5. Less than 0. And then we have this negative right here. So let's distribute it. So now I just change the signs. Now I have 2x plus negative 3x, which is negative 1x. And then I have negative 7 plus 15, which is positive 8, all over x minus 5. Boom. Now we can finally get down with this thing. Now, in order to do this, we have to find all the zeros, all the critical numbers. Well, zeros are the critical numbers like we did the last one. And we have to find the asymptotes. So the asymptotes are also going to be considered critical numbers. So we got to find zeros. In order to do that, we're going to take the numerator and set it equal to 0. And we have to find asymptotes. So we're looking for asymptotes right now. And to do that, we set the denominator, x minus 5 equal to 0. So we get 2 answers. We get x equals 8, and we get x equals 5. These are our critical values. So we're going to put a 5 here and an 8 right here. How many intervals do we have to test? 1, 2, 3. Only 3 intervals. So give me a number in this interval right here. Come on, shout it out. 4 is good, but 0 is better. All right, give me another one. 6. Give me another one. 9. It has to be greater than 8. So we got 6, 9, and 0. We're going to plug these dudes in. Let's do these in our head, shall we? 0. I plug in 0 right here, and I have an 8 on top. If I plug in 0 right here, I have a negative 5 on the bottom. So I have 8 over negative 5. Is my answer going to be positive or negative in this interval? It'd be negative. Because why? We have a positive 8 divided by a negative 5. Positive divided by negative is a negative. All right, next one. We have a 6. 6. We plug in 6. Negative 6 plus 8. What's negative 6 plus 8? Positive 2. Positive 6 minus 5. What's that? So positive 2 divided by positive 1. What do we get? Positivo. All right, now we have a 9. Plug in the 9 up here. That's a negative 9 plus 8. Negative 9 plus 8 is? Negative 1. And then down here we have a 9 minus 5, which is a 4. Negative 1 divided by positive 4 is going to be a negative number. So where are my solutions? This says, where is this less than 0? So this has to be negative. All right, now pay attention. This is a weird thing. These are my 2 intervals that work. This one and this one, because they give me negative numbers. And so I have negative infinity to 5, and I have 8 to positive infinity. Okay, the question is, I know we have parentheses around the infinity signs because there's always parentheses. Does a 5 get a parenthesis or a bracket? 5 is where the asymptote is. We cannot have 5 in there. We cannot plug in 5. So that means 5 should be parenthesis. What about the 8? 8 is just a 0. 8 would make this 0. Equals 0. Yes, 8 works. All right, those are your answers.